my part within Stratasys is running our consulting division, our strategic consulting division, which I have to say is possibly more fun than being the GM. Because what we get is to see lots of companies around the world who are trying to understand this technology, embed this technology, make the most of additive as an approach to making products. So I'm going to slant this presentation somewhat towards the strategies behind 3D printing, the strategies behind additive manufacturing. Who regularly uses RP? You're not all vendors. There must be some users. Look, there's some users. Worryingly not enough. There should be more. Who's using this tech to make tools? Not quite so many. Some people, but not so many. What about jigs, fixtures? Okay, an equal number of people. What about end-use parts? Oh, not as many hands popping up in the air. That's, on one hand, slightly worrying, and on the other hand, is a marvelous opportunity. So I'm going to talk predominantly about end-use parts, because it's something I'm very motivated about. Rapid prototyping is enormously important. Rapid tooling, jigs, fixtures, a really important part of our industry. In terms of strategy, the thing that's more important is companies understanding how to embed the concept of making things layer by layer into a business. Who wants to make more parts using additive manufacturing? I'd hope to see a few more hands popping up in the air than are already using it. And we've heard all the different reasons why people are not using the technology. It's not fit for purpose, the materials are not good enough, it's too expensive, the machines are too slow, they're not big enough, I can't certify the material. Lots and lots of technological reasons. We'll look a bit beyond that at some more structural business reasons, but people want to use the technology to make end-use parts. So the title that Andy was given was 3D Printing, Futures and Perspectives. I'm going to mix the words around, because that's my prerogative, to perspectives for a 3D printed future. Same words, means a different thing. So I'm going to lead you through really where I see a 3D printed future, or what companies need to do to get to a 3D printed future. I think the future is bright, no matter how you look at it. There's lots and lots of very well-respected global analysts out there making predictions about the size of this industry. McKinsey stating that this as an industry could be worth $100 to $200 billion. What do they mean by that? Do they mean the companies that are at TCT will all turn over between them $200 billion? No. What they mean is the products that are made using additive technologies could have a value of $200 billion. The value is created further up the value chain. And that's what I want to talk about, is how we identify where to create value using additive manufacturing. Lux Research, significant growth, significant markets by 2025. The markets are growing in certain vertical sectors, and we know that. Aerospace, automotive to a lesser degree, medical to a significant degree. And I'm going to talk a little bit about why certain sectors are adopting this technology more than others. So, if you strip all this back to basics, I'm standing here because I want the world to make things using additive manufacturing, 3D printing. I want you to make things layer by layer, not by machining or molding or casting, but layer by layer. And I think there's two ways that we can drive that $200 million or $200 billion market space. The first one is what we do now. We find products and business models that exploit the benefits of 3D printing. You go and look at all the case studies that have been published about 3D printing. That's what we've done. We've taken today's technology and we found an application that makes manufacturing sense. The inverse of that is we make the technology fit for purpose in the future to fit what manufacturers need. And that's the cusp that I think we're on at the moment. Taking RP and actually making it into AM. That's the difference, making technologies that are fit for purpose for production. I'm going to focus more about the former area here, about how you identify business models to fit them onto today's technologies, because it's not my job to stand up here and tell you about technology roadmaps. So, before we start, big question. Why are we all interested in 3D printing? Why do we want to change the world? Why do we want to not mold things by the billion in China? Why do we want to be responsive to customers? What's changed? Why is the world different now? Because this tech was invented 30 years ago. And we weren't making things 30 years ago by 3D printing, but we're trying to do it now. So something's changed. Why do we need these new tools to do old jobs? Or why do we need new tools to do new jobs? What's changing? And something I'm really passionate about is the whole issue of socioeconomics, looking at what is it in society that's driving us to want to make things differently. And there are some huge changes out there that really cross over with 3D printing. Societal changes, aging populations, wealth disparity, issues around new diseases, old diseases, growing populations. Society's changing and we're driving consumers to think differently about the things that we give them. Culture is changing enormously. The way that we sell, the way that we market, the way that we engage with consumers. Even if we're an airline, even if we make aerospace components, ultimately at the top of our value chain, we're engaging differently with consumers. The environment is changing the way that both consumers and manufacturers think. And that's driving the demand to want to look at things like 3D printing for resource efficiency. And global economics. There's enormous opportunity all over the world to sell product, but can we really work in all of these different marketplaces? Can we service them from centralized factories? No, we can't. But these are the drivers, these are what we call the global megatrends that are driving companies to think, maybe we need to do things differently. We need to reinvent the way that we configure the factory. There's been an awful lot of talk recently about reconfiguring factories and industrial revolutions, and I hate this idea that 3D printing is the new industrial revolution. That's nonsense. It's not an industrial revolution, it's a manufacturing technology. It just makes things in layers. That's not an industrial revolution. If you look at industrial revolutions, there have been 3 of them to date, they've had profound changes on the way things that were made. Harnessing power, mechanization, Arkwright's original concept of the mill structure, moving through to Henry Ford and moving through the steel revolution, and then the IT revolution, communications and digital. Where we are now is something really, really exciting, and something that we're looking at in a lot of detail at the moment is this idea of what's called Industry 4.0, which is truly an industrial revolution. 3D printing is a part of it, it's a subset, it's an element of it. And the idea of 4.0 is it's about connectivity. And it's a German concept by origin, so some of the wording is a little bit harsh, but connected value chains and cyber physical systems. What does that mean? It basically means joining things together. We live in a world where we can join things together. And by that, I mean I can join my son and his iPod through the things that he buys, through the internet to the companies that make things, that haven't made the things that he wants. And he can be the designer who is the one that actually drives the PLM system to make the product. Yeah, and if I pay for it on my iPhone and give him the credits to buy the things he wants, we can initiate a transaction that drives the factory, that's integrated with the logistics back end, that makes sure that he gets the product tomorrow. That's Industry 4.0. It isn't a factory that's mechanized, it's an entire supply chain that's mechanized. And it's driven by this wonderful world, the Internet of Things. My son's iPad or iPod is his Internet of Things device, as is my car that talks to my dealer. This is what the Internet of Things is, and it plugs into Industry 4.0. We believe 3D printing plugs in really beautifully into the middle of that concept because it's infinitely flexible. Scott from HP spoke about this earlier, this idea that we have an infinitely flexible technology to make products that we don't know what the shape is yet. So what does it really mean? Well, I think this is a chart that we've been using for a few years, but I think there's a different economy emerging between consumers and manufacturers. And at one end, you've got consumers who buy absolutely everything, like my wife, and you've got companies who make everything to stock and sell it. And at the other end, we're getting to this world of consumers who want to make everything. Maybe it exists, maybe it doesn't exist, maybe it's a pipe dream. But it's the other end of a scale. And the scale is consumers who make everything and brands that make nothing, through to manufacturing companies who make everything and consumers who buy everything. And actually what we have in the middle is where I believe we are today, which is companies who make only what consumers demand and consumers who want to personalize the things that manufacturers make. That's Industry 4.0 and 3D printing. So that's the space for change, the Industrial Revolution. And it's an exciting time to be at. And the brief today was talk about the future. Well, I think this is where we are. And technology and digitization is going to drive us towards this becoming far more of a reality in all different supply chains. We've got two extremes here, two extremes of this spectrum. We've got manufacturing factories, dark satanic mills, and at the other end we've got little Johnny at home with his MakerBot on his table. He is his own factory. And in between we have everything else. And we're here in TCT. And TCT, interestingly, 3 or 4 years ago decided to have 2 shows under one roof, one for one end of the spectrum and one for the other, Personalize and TCT. So going to talk about both of them and how they actually come together in an ecosystem. So consumer 3D printing and industrial additive manufacturing. So let's just give you a whistle stop. Where are we today? Where's the future going for consumer 3D printing? Whether we as a company like it or not, the capabilities of low-end 3D printers are increasing almost exponentially. If you look at the speed of development and walk around the show floor, what we used to call low-end 3D printers, we no longer call low-end. We refer to them kind of as just lower or low cost. They're very capable technologies. And if you look at the speed of development of some of them, like MakerBot, going from ostensibly an online shared collaborative idea through an embryonic company to a fully worked up engineered solution. Very rapid development. So, low-end 3D printing is getting better, getting more capable, higher productivity, more accuracy, and that will just continue. Another thing to consider is that we used to say, well, 3D printing will never catch on, it's too expensive. Well, it isn't too expensive. You can buy 3D printers cheaper than Xboxes. Whether they give you as much pleasure and satisfaction and feeling of belonging and community is another matter. At the moment, maybe they will in the future, but they're cheaper. So if money is the barrier, it isn't the barrier anymore. So they're getting better, more technologically capable, and coming down in price. The other thing, linking back to what I said about Industry 4.0, they're becoming Internet of Things enabled devices. They're already becoming part of this future supply chain. So if you look at the MakerBot, look at the sensing on it, look at the feedback, look at the cameras, look at the apps that run it. It's an IoT device, and it's not the only one. That's a trend that we're seeing emerge more and more and more with lower-end 3D printing technology. The ecosystem itself is becoming intelligent. One of the barriers, or the perceived barriers that's stifling the growth of consumer 3D printing is nobody's got anything useful to print. We can only have so many candle holders and plastic necklaces and bangles and owls and lions and so on. We have to have something valuable. The problem is things that have value tend to have intrinsic value locked up in their IP. Do I really want to give away valuable data to somebody? No, I don't. And that almost destroyed the music industry and the film industry, and we have to find new business models. And we already are. In 3D printing, we're seeing companies like Authentize who are streaming data to people's 3D printers. Because consumers don't want data, they want objects. So actually, why don't I stream my data? Because at the moment, we're all used to streaming. We all use Netflix, we use Spotify. That's a different methodology of getting parts to consumers. This ecosystem's also getting connected. So I remember maybe 10, 15 years ago, we started talking about the idea of additive manufacturing would be an amazing thing if we could connect machines around the world into virtual factories. And I don't think we could have ever conceived that that would happen, but it would happen by consumers being virtual factories and then linking themselves together. So I don't know if these guys are here today. There's an amazing company based out of Amsterdam called 3D Hubs. They have 27,000 printers linked together in a network, a self-selecting network. What's interesting is not all those printers are consumer printers anymore. There are service bureaus linked into this. Thousands and thousands of machines waiting in people's homes for people to become factories. And the old adage that you're never more than, 8 feet away from a rat, which makes either Loic or Andy a rat. I had a look this morning, so I've gone 3D Hubs. The nearest hub to here is Jeremy's hub. It's 14 kilometers away. So there we go, there's our virtual factory. It's 14 kilometers away from here, and we can use an iPhone app to get it making things for us now. Using internet-enabled devices in a configured network with data streaming to it. Oh, hang on. We're breaking down all the barriers to why 3D printing's not such a good idea. And of course, that in itself is driving business model change. So some companies have already wised up to this. They've cottoned on to, hang on, there's a slightly shifting world order in the way that things are made. Fairphone is a really neat company who they've kind of decomposed the whole capitalist model of manufacturing and said, why don't we share with the world what our bill of materials is? Why don't we tell you what all the component parts in our mobile phone are? And we'll tell you how much we pay for them, and we'll tell you how much our R&D costs, and our channels cost, and our marketing, and we'll tell you what our profit is. And if you're happy with that equitable model, you can buy our product from us. Oh, and by the way, if you want to print the covers to your phone, well, there's a voucher. Now go and get the guy next door to do it for you and build a community. So the component parts for Fairphones are actually coming from that 26,000 people distributed global factory. And that's how Fairphone are then engaging with consumers and people to buy their phones. So a totally different business model. Okay, it sounds wonderful. Let's stop. It's not all as wonderful as it might seem. You know, if you have a consumer 3D printer, you've probably created one of these wonderful things. I created one yesterday. Wasn't what I expected. It maybe wasn't as bad as that. You know, one of the criticisms is consumer 3D printers are not capable machines. They're not capable of making products that have any value. I'm not going to put any pictures up here of good parts. I just implore you to walk around outside, go and look at some consumer 3D printing companies, pick up their parts, drop them on the floor, throw them against the wall, and make up your own mind. Are they good enough? For some applications they are, for some they're not. So that's the consumer 3D printing current position. Now start imagining where that would be. So we already have accessible, low-cost, capable, internet-enabled machines in connected ecosystems that we can stream data to. That sounds kind of a bit futuristic. Well, it's not at all futuristic. The bits exist. Maybe we just haven't plugged it all together yet. So this is TCT and Personalize. That's kind of the Personalize side. TCT, industrial additive manufacturing. Let's talk about that. So you guys know all this. I could stand here and espouse about all the amazing things we can print on Stratasys machines, and we can do color, and we can do ABS and Ultem and lots of different materials. And we can make prototypes for form and fit and function, and hopefully you guys know all this unless you're in the wrong show. I'm not sure what the one next door is. And even if you went in there, you should probably know this anyway. So prototyping, tooling. You know, we had a bit of a show of hands earlier. Not as many of you know that we can use the technology for tooling. The technology is moving on. We're getting better, more resistive, robust materials. There's some great tooling applications that we're seeing now with industrial additive tech. Making injection mold tools. Sounds illogical, but making plastic injection molding tools to inject plastic. But we can do that now. Sheet metal forming. Who would fathom that you can make a plastic forming tool to press a metal part? We can. Composite layup tools. We can print the tool that we lay the composite around, therefore mitigating the need to make a tool. Or vacuum forming, blow molding. There's lots of tooling applications that are emerging that this technology fits around. Production aids, grippers. We talked about this earlier, you know, automation, drilling guides, lots of applications on the shop floor. People need to know about this. The question is who in a company? Now, our thinking is it's probably the lean guys in your company that need to know about this. This needs to be part of the toolkit for lean manufacturing practitioners who are looking at alternative ways of keeping the shop floor running. And manufacturing, you know, the one that I'm really passionate about, making end-use parts. People really need to know about this. So another show of hands to wake you up again. Who's got an additive manufacturing strategy in their company? Written down? Communicated with the supply chain? With standards? Bought into by management? Intrinsic to the overall business? Good man. One. In a room of 200 people. This is the bit that we're really passionate about now, is strategy. And that's, I guess, why I got the gig to stand up. Helping companies develop strategies. What is a strategy for additive? We think there's a 3-stage approach you need to take. Opportunity analysis, solution identification, and development of a strategy. Don't go wading into the strategy until you understand why you need it. I'm going to share with you some of the things that we've been doing to take people through this journey. So opportunity analysis. People get emotional about 3D printing. If you've never seen it before, it looks amazing. And 20 years ago, when we all saw it for the first time, we sat there with a cold beer watching laser beams dancing around, and it all looked magical. And it still does look magical, but that shouldn't get us emotional in business. There has to be a reason to use it. You know, current technologies have been around for millions of years. You know, fabrication and formative, fabricative techniques. There has to be a reason, and we think there are 3 reasons to use additive, or 6 reasons, sorry. Low volume production, mitigating tooling, increasing product complexity, making really complicated shapes, cost-effective personalization. And that couples the first 2 together. We're all a different size, shape, whatever. There's 7 billion people, 7.2, 7.3 billion. Economic production of different shapes, that's personalization. And that's where this technology fits beautifully. Environmental sustainability, again, one of our drivers I spoke about. We need to be more resource efficient, whether that's because of polar bears having nowhere to live, or whether it's because the cost of our raw materials is going up. There are reasons why we have to be more sustainable in the supply chain. Optimizing the supply chain, changing the retail model. There's another reason to use additive manufacturing, a way of challenging the status quo, and increasing part functionality. So I'm going to give you a couple of examples of what I mean by some of these things. So, economic low volume production. This is, again, a Stratasys example. I don't know if these parts are on the exhibition stand. They might be. And it's a motorsport company. Well, what do we know about motorsport? Very high value, very low volume. Time is absolutely of the essence. Engineering things that are high quality. So Straco Racing use additive manufacturing to make component parts for race cars. Why would they not do that? It's technologically capable, it's economically viable, it's highly responsive, they can produce parts in under 24 hours, they can make parts for specific races. That is low volume, high value manufacturing. And it's not unique to motorsport. It exists in aerospace, it exists in medical, it exists in the consumer domain. Personalization, I always draw back to personalization because I think it is the perfect application of additive technology, making things that are fit for purpose for individual consumers or patients. Another example, great example, is prosthetics. If you look at the traditional way of making prosthetics, it's invasive to people, it's uncomfortable, it's slow, it's not optimized. We can make custom prosthetics by taking scan data from patients. We can print prosthetics and we can change those prints as people change. We have data, we can modify data. Personalized products. This is, I guess, at the moment, one of my favorite case studies is some arguably crazy people in New York who decided that Manhattan was a really good place to build a factory. Actually on kind of 6th Avenue, 6th and 47th, I think. Let's put a factory in the middle of New York. Where is it? 27th. There we are. I was a long way up the island. Let's make a factory in New York. What a great idea. Highest cost real estate in the whole of North America. But what we'll do is we'll link it to what's omni-channel marketing. Omni-channel marketing is basically all the other ways of getting to people. The internet, or through catalogs or whatever. And the normal business model is really quite neat. So they said 3D printing is exciting, people want to see it, so I'm going to put it in a retail environment, and if people walk in off the streets who want to buy headphones, I'll take scan data of their ear and I'll print them headphones. But I'll spend most of my marketing money on the internet, driving custom through the internet. And we'll make those products in our virtual factory that's exciting for people to see. And then we'll ship the parts out. And that's their business model. It's a totally different model. They only make things when they have an order, when they have a customer. There is no stock. It's a completely stock-free, cash-positive business model based around product personalization. In this case, in-ear headphones. So if we look at this, most business models where additive manufacturing is being used today exhibit at least one or more of those business drivers. So when you see all of these news articles in The Economist or in TCT or whatever saying company X is using additive manufacturing, read the article and map it against that matrix. And you will find that the reason they're doing it is for one of those business reasons or multiple business reasons. GE making parts for their LEAP engine. Well, why? Well, they're doing it because they get a very high complex geometry that gives them an optimized engine component that reduces the environmental burden of the aircraft. That's why they're doing it. It's not because 3D printing is fun and funky. There's a business reason behind it. So whenever we start a strategy with people, our starting point is this. What is the reason to use 3D printing? The other thing you have to do is understand the strategic imperative in your company. What's your company trying to do? What's the pain point in the company that 3D printing addresses? Is it quality? Is it cost? Is it delivery? Is it innovation? Is it perception of you as a Luddite? What is it that you're trying to do at a corporate level? Are you trying to get closer to your customer or further away? Are you trying to centralize manufacturing or decentralize it? Because actually that's how you have to apply the rationale to decide whether 3D printing is a good idea. So we use an approach to this called meta planning, where we try and position great ideas for 3D printed products against a pretty simple matrix of sense and logic. Do you actually get a return on investment here to your business? Will your business make money? How risky is it to try to implement this into your business? And we'll try and work out a risk versus reward framework for using 3D printing. Because when you've done that, you then have the whole feasibility issue. Does an idea make technical, economic, social sense? Will people buy what you actually want to 3D print? This is the questionable bit at the moment. There's a huge amount of 3D printed. A good friend of mine calls it shishi. There's loads of shishi, it's everywhere. Yeah, there's lots of businesses popping up on the internet trying to sell as shishi. More fruit bowls, more plastic earrings, more, yeah. Are people really going to buy this stuff if you invest in the technology? Are you going to be able to sell it? And this is where standards comes in, and legislation. It's all well and good having a great idea for a product, but is there a legislative framework that stops you doing that? Can you make the value proposition greater than the manufacturing cost? And this harps back to my comments about the barriers. People say additive manufacturing is so expensive, the parts are so expensive, your materials are expensive, your machines are expensive, they're slow, the piece parts are expensive. Okay, well look for a different value proposition. If the thing's expensive, we have to find a different way of positioning it. We have to find a different business model to sell it. Is it fit for purpose? Do we have materials, machines? Is there a way of doing this? We have a lot of tools that we've developed in the last 10 years to go through this process. Because you want to go through this before you make any sort of capital investment. And then you get into implementation. What is a true additive manufacturing strategy? And it starts off actually looking more at the business than the technology. If you're going to 3D print things, if you're in the medical domain and you want to make 3D printed prosthetics, orthotics, scapulars, okay, that happens in a factory, but what about the rest of that whole value chain? How are you going to engage with the consumer or the patient? How are you going to deliver to them? How much is that all going to cost you? How much does it cost outside of the centralized manufacturing? Are you going to go online? Are you going to vend in a retail environment, healthcare environment? Are we going to put machines into hospitals or into shopping malls? What does a strategy truly look like? Also, who's going to make these things? Lots of companies outsource. Some people insource, some people outsource. What is the optimum configuration for a 3D printing supply chain? Do you make a small capital investment and hedge your bets, and then look towards service bureaus to make parts for you? Or do you go wholly to service bureaus until you can prove there's demand for the things you want to make, and then make a capital investment? Again, that's part of a strategy. And then where are you going to actually deploy resources and people? What are the skill sets of the people you would need in the 3D printing supply chain? Particularly if you're going to start engaging with customers and scanning them or taking personal data from them. Is that the job of a retail worker on minimum wage? What are the considerations there? That is all really where strategy leads us. So just to finish off, our belief is you can only address this by looking holistically across a business. Where does a business really want to be positioned at the moment and in the future? What are you going to make? Is it data? Is it parts? Are you going to own an element of a supply chain, or are you going to own an element of technology? That to us is 3D printing an industry 4.0. So just to summarize, perspectives for a 3D printed future. I think it's fair to say the tech is here, and it has been for a long time. It's maybe not as dominant as people would like, but it is growing. We are disrupting traditional supply chains. There are already traditional supply chains that we can map out and show significant disruption, particularly things like investment casting, where we're either going to direct metal parts, or we're disrupting the way that traditional waxes are made that support the investment casting industry. Because we're not making tooling and injecting wax anymore, we're printing patterns. So we are causing disruption. I think it's important, this idea of enabling a response to socioeconomic change. We're living in a world of change, and we have to think of ways that manufacturing can adapt to that. Comes onto that 4.0 issue, Industry 4.0. We're living in a more connected world, and we have a technology outside that needs zeros and ones, as Scott Schiller said earlier. We can't drive it without zeros and ones, and that's what the whole connected society is about. And that's very different to molding or even CNC machining, because we don't need jigs and fixtures. All we need is digital data to drive the manufacturing in our supply chain. I suppose the final point I would say is that you have to decide in a company who the right people are to drive a strategy for 3D printing. And I'll stand up here and put my shield up in front of me. It's probably not the people running the RP machines. because you're pretty busy, you're involved in product development, not in strategy development. You probably are not party to knowing where the company is actually trying to get to in the next 10 years. You may be if you're in a lucky position. What you have to do is upsell or be responsive to people above you looking down. You need to engage with people in IT, in marketing, in strategy, in manufacturing, in supply, logistics. And actually that's all those elements of Industry 4.0.